I am Vityasri Ramachendren, along with my teammates Daniel Au Li Qian, Dhinakharan Raja, Kaviraj Maniveel, and Pravendran Ravi. We are going to study and give a review about refraction of light.
Firstly, let me explain what refraction of light is. Refraction of light is a phenomenon where the direction of the light is changed when it crosses the boundary between two materials of different optical density. It occurs as a result of a change in the velocity of the light as it passes from one medium to another. Next, we are going to look at the law of refraction, also known as Snell's law. Snell's law states that the incident ray, refracted ray, and the normal at the point of incident all lies on the same plane.
The relationship between the angles are summarized as following. Refractive index equals to n1 sine theta equals to n2 sine theta. The angles refers to the angle of the ray. N1 and N2 are refractive indices of media 1 and 2. The refractive index, or the index of refraction of a material, is defined as n equals to c over v, where the value is always more than 1. C stands for speed of light in vacuum and v stands for speed of light in medium. The wave speed and wavelength of light change as it travels from one medium to another, but the frequency remains constant. So the refractive index of a material is n equals to wavelength of light in vacuum over wavelength of light in the medium or material.
For this experiment, you'll need a round-shaped glass cup or vase, a paper printed vertically with 2 arrows. Step 1. Fill it up half full with tap water. Step 2. Place the glass cup or vase on a stable surface. Step 3. Place the paper with printed arrows behind the glass cup or vase. Step 4. Now, observe the arrow's direction. As you can see, one of the arrows has changed its direction. This effect is caused by refraction. Refraction is the bending of light when it passes through different mediums. This is also caused by density. Light travels slower when it travels to dense medium. Water is denser than air, therefore, the speed of light travels slower. Now, this is our arrow, and here is the light rays coming off it to our eyes. When a glass of water is placed in between, the light rays bend. The head and tail of arrow is bent in towards the center or focal point. They cross over each other and open up again, but now the light from the head and tail of arrow is flipped, causing it to change its direction, thus causing the illusion of reversed arrows.
So that was the result of our experiment. Apart from our experiment, there are also many applications in our daily lives that involve refraction of light. For example, catching or viewing a fish from a pond. When we immerse a straw into a cup, it's not straight when we see it from the side angle, and many more.